All right, in this section, we're going to look at 7.2, and we're going to be approximating the population mean, just like we did in 7.1, with a slight difference. And that's what this big thing is going to be about, this with the difference. Okay, so we're still going to try to find an interval around a sample mean to figure out like the average population, or the true population mean is somewhere in that interval. But now we don't know the standard deviation, whereas before we did. So we're going to have to use the sample standard deviation. And since that's not exactly correct, we're going to have to try to kind of compensate for that. We're not going to use the Z tables anymore for when we don't know the standard deviation of the population. And just keep that in mind from now on for the rest of the course. Anytime we talk about not knowing the population standard deviation, you should immediately think, okay, I can't use the Z table. Whenever you don't know sigma, don't use the Z table. All right. Instead, we're going to use what's called the student's t distribution. So we're not going to use Z's, we're going to use t values. And it's going to be similar. A lot of the stuff's going to be similar, but the chart looks different. It's going to have different values in it. All right, so let's talk about this t distribution. It is a normal distribution with a mean of the mean at 0, just like the standard normal distribution. So this is a normal distribution. It's bell-shaped curve, and it could be converted into using, you could turn t values into Z values and whatever. We're not going to go down that road, but it is a normal distribution. The area under the curve is 1, just like the standard normal distribution. That matches up, but there are differences between them. This is actually going to be a whole set of different distributions, where the different distributions are their widths and heights and things are affected by the sample size. So you got one for a sample size of 10, you got a slightly different curve for a sample size of 100, so you have all these different curves based on the sample size. And we're going to bring up this new idea called degrees of freedom, and it's going to be one less than the sample size. It's always going to be one less. So if we have a sample size of 10, your degrees of freedom are going to be 9. And you want to be careful that you don't use sample size for degrees of freedom, and you don't use degrees of freedom for sample size. They are related, but they're not the same number, and it'll mess up your calculations to mix those two up. Excuse me. The deviation is greater than the standard normal than the standard normal distribution. What that means is things are more spread out, which means since the area is the same, your curves are going to be a little bit shorter. We're going to look at a couple comparison curves just to kind of see how that works out, but they're going to be wider. They're going to be wider and shorter. And then the greater your degrees of freedom are, the more closely this is going to get to the Z values, to the standard normal distribution. So the higher numbers of degrees of freedom. Now we're talking about, like, to be match up perfectly, you need an infinite number of degrees of freedom. We're going to have less than that typically. So we're just going to use what we got. And we're going to use this t value. So you can't just switch and swap them however you want. You got to use the t values when we don't know the population standard deviation. All right. So here's a comparison picture. The red curve is your standard normal distribution, your Z values. And then here's a couple of different T curves. The blue is 5 degrees of freedom, so a sample size of 6, one higher. You can see it's wider than the red curve, but it's shorter. And the same thing with the tan or brown, light brown curve. It's also 2 degrees of freedom, so a sample size of 3, and it's also a little bit wider and shorter than the red. Now they're close, but it's not the same. It's not the same. And so their standard deviations would be different, and how spread out the data is different. There's more area on the tails. As if you look at the ends there, if it's the higher it is, that's more space under there, the more area it is in there. Okay. All right, so this is what the table looks like for the thing. And this was in those stat tables I put on Canvas under modules where the Z tables were. So this would be like the third in that list. There were two in the two Z tables, and this would be the third one. If you haven't printed it out, pause the video, go print it out, and come back to this. So you have it on hand, and you can see it, because this is kind of small, a little hard. I'll do my best to kind of explain it, but it's going to be a little hard to see on the screen, just so you're aware. Now, there's a lot of information here. We're going to get into all this information eventually, but not today. What we're going to worry about today is this row here and this column, right? And then the space inside, okay? So there are some different things about this than the Z table. First of all, if you look at this picture up here, it kind of tells you what's going on. We're going to have a certain confidence level. So you'll say, you know, what if I have a 90% confidence level? Well, you want the area in the middle to be 90%. That's what this top row is. What percent confident you are, how much of the area should be under the curve there. So it's going to be telling you the middle area, and it's going to tell you a t value that for the middle area will be between negative t and positive t. So it's going to give you one t value, and you're going to have a negative and positive t to be in that middle area there. So that's one thing that's different, because remember the other charts, they always went from a certain spot down. This doesn't read that way. It's from the middle spot, but you're also starting with the area you want. And we didn't start with that. We started with the Z value, and we found the area. Here, you're starting with the area, and then you're going to find the t value. So that's kind of flip-flopped from the other one. We did a few problems where you would look through and find a certain percentage or area, and then backtrack the calculation, but that wasn't really how the table was set up to do. This is set up. You start with the area you want to get in the middle, and then your number of degrees of freedom, and then you cross-reference that to find the t value. So these are the t values. This would be the t value for 7 degrees of freedom at a confidence level of 85%. So my C value is 0.850, and I have 7 degrees of freedom. And that would give me a t value of 1.617. So in the middle here, these are the t values, not the percentages. These are the t values. So that's flip-flop from the Z table. So that's another difference there. So let's use this. So let's do some calculations here. All right. So just kind of going on here. So the problems we're going to be doing are very similar to what we did in 7.1, setting up these intervals. Again, we're looking at degrees of freedom. That's one less than the sample size. So some formulas here. So again, your confidence level has to be between 0 and 1. So they're going to give you a percent. You're going to turn it to a decimal. It can't be 0, can't be 1, right? But other than that, it can be any. You could have a 1% confidence interval. You could have a 0.999 confidence interval. Whatever that is. Now, again, going back on that chart, there's only set ones it's set up for. It's only set up for a 50% confidence, 75%, 80, 85, 90, 95, 98, 99, and 99.9% confidence level. Anything other than that, this table, you might be able to estimate it. I would always go higher. Sorry, I would always get a higher t value. I would never get a smaller t value if I had to estimate. So, if it said I wanted to be 97 and I had 7 degrees of freedom, I would go ahead and do 98 on the chart. I would use that t value. Just because you always want to be a little bit, you want to always go bigger, because that means you're going wider and it's safer. The wider you go, the safer you are. There was a car tire commercial, wider is better or whatever. I mean, that's how it works in statistics. The wider you get, the safer you are. It also means the less maybe useful it is, but it's also safer, that you're like, yeah, it's in there somewhere. Well, that's a pretty big space. Well, yeah, I mean, but I'm more confident that it's in there. So I shouldn't say that. I'm more sure that it's in there. All right. So it's got to be between 0 and 1. Degrees of freedom, again, that's 1 less than the sample size. Maximum margin of error, and I think in the last video I kept mixing up margin of error and whatever. We're just going to margin of error. So this is the maximum. margin of error. And it's very similar to the formula we saw before. The other formula we saw in the last one for this was Z based on the confidence level, sigma, and the square root of n. So sigma and Z can go together, but we don't have sigma anymore in this section. I mean, we'll come back, we'll do problems where we do know sigma, but since we only have the sample standard deviation, we're going to use T. So S and T kind of go together. So, but it's the same formula we use. It's just we're using S and T instead of sigma and Z. Okay. And then the confidence interval is going to be your sample mean minus this margin of error and your sample mean plus this margin of error. And again, what's happening here is you have some kind of population and you don't know what that population really looks like. We don't know its standard deviation. We don't know its mean. We take, you know, some values from here and we get, you know, a mean. We get a mean value. And what we're doing is we're setting up an interval where we're saying, you know, if we go a little bit left and a little bit right of that mean, we're hoping the actual mean based on this confidence level is going to fall in there, in that interval. You know, it's not going to be right where the X bar is probably. This is probably going to be either below or above it, but it's going to be somewhere in that interval. We're not sure which way it is. You know, in this picture, it's clear the actual mean is above, but you know, realistically, you would not have that picture to go by. You would just have your sample mean in your interval, and that's what we're constructing here. And this just switches that in. Again, I wouldn't use this formula. I would instead calculate the maximal margin of error first, and then just use that to figure out the interval. That's how I'm going to do it when I do examples here. I would not try to do it all in one step. I would do it in different steps. All right, so we're gonna figure out the appropriate t-scores based on confidence levels and degrees of freedom. So here's 3 things we're gonna do, and we're actually gonna do it. I'm gonna do it together with you to figure out what these are. So I can show you how to read this table. So for the following conditions, a confidence level of 90% and a degrees of freedom of 12, that means the sample size is 13. Confidence level of 90%. Degrees of freedom is 50. That means the sample size is 51. And again, degrees of or confidence level of 80% with degrees of freedom of 50. Again, that's 51 sample size. So let's look at this table again. We're trying to figure these out. So 90%. So here's 90% and 12 degrees of freedom. And I cross-reference that and I get this number. 1.782. That's my T value. Okay. You can put T sub C for confidence. All right. So then let's do the second one. So T sub C, 90% again, but this time we're going to go down to 50. So 50. And what I find is useful is sometimes is just to get a couple extra pieces of paper and just kind of cover up, you know, and then you can see the little corner where they meet. That might be a little bit easier. So 1.676. So notice same confidence level, but we increased the degrees of freedom, and that made our T value smaller. The larger the sample, the smaller your T value is going to be, keeping the other things equal. So, you know, you basically, remember, we're creating an interval. If you get a larger sample, you can make that interval a little bit more precise, a little bit more small there, you know. And then on this one, now we're keeping the degrees of freedom the same, but we're reducing the confidence level. So this time we're going to look at an 80% confidence level, and again 50. So it looks like right there. So our T sub C is 1.299. And so notice by reducing our level of confidence, we can reduce the size of our T value here, you know, pretty substantially, if you're willing to be less confident. So, and that was true when we talked about Z values. The more confident you are, the wider you have to go, the bigger the Z value. The less confident, the smaller you could make it, but that's because you're less sure that that mean is actually in that interval. So if you look at those formulas, the things that can affect the margin of error is the t-value, and we just talked about a couple ways you can affect the t-value. Standard deviation can affect it. Larger standard deviation, the larger that margin of error is going to be. And then the sample size directly, the bigger the sample size, the smaller the margin of error directly. And also affects the size of the t-value, indirectly, because it affects the degrees of freedom. So, if you make a smaller sample, you're going to have a larger margin of error. All right. Let's have you do questions 1 through 9. Pause the video and then come back and do those problems. Okay, so let's move on. Let's look at problem 384, number 18 here. 384, page 384, number 18. What percentage of hospitals provide at least some charitable care? Okay, and so they're going to ask us, they give us a list of values here, and they ask us to use a calculator with mean and sample standard deviation keys to verify that. So I don't know if I've ever shown this before, so we're going to get out of that real quick. I'm going to pull up my graphing calculator, and I'm going to put this stuff in. I'm going to show you how to do this. So if you want to put in a set of data, what you're going to do is you're going to go to your stat button, click that. And the first thing it's going to say is edit, and I want to select that, so I'm going to hit enter. And you notice I have some values in here already. I don't want those values. Now, what I'm going to do, be careful when you do it, because if you mess it up, you have to do some manipulation to kind of get it back, or you need to reset your calculator. So what I'm going to do is I'm going to go up to the top and highlight L1. And this is where it's dangerous. I'm going to hit clear, not delete. Clear. I'm going to hit clear, and notice I'm going to clear out that list, and then I'm just going to hit enter, and it's all cleared out. If you hit delete, you will delete the column. No more will you have an L1 column. Don't do that, okay? You can fix it, but it's really annoying, so don't do it. Move up there, hit clear, enter, and then you're good to go. All right, so now I'm going to type in the numbers from 18. So 57.1, 56.2, 53.0, I just 53, but 66.1, 59, 64.7, 70.1, 64.7, 53.5, and 78.2. Okay. And once I have that in, the next thing I want to do is I want to calculate the data for this. So I'm going to push my stat button again, stat, and I'm going to go over to calculate. And the very first one variable statistics, and I'm going to select that one, and I'm going to hit enter. And there are the statistics. So there is the sample mean, and I'm going to write this down. Let me move this over here. I'm going to write this down for 18. My sample mean. Why aren't you getting? Okay, my sample mean is 62.26. My standard deviation, that's what this is SX, S sub X, 8.0, what do they say? 8.0 is what they say. Okay, so these are, and they round this to 3. They round this to 3, and these are percents, okay? So 8.0%. So this is talking about, based on this report, the following obtain units of percentage of the hospital provide at least some charitable care, okay? And And so, yes, this does look like it matches. Another thing I'm going to get from here is notice it has n. N equals 10. Just 1 second. All right, sorry, I had to help somebody with some math. Yay. Let's see what we got going on here. So I'm kind of forgot where I was. Oh, all right. So we did the one variable statistics. We verified the standard, the mean and the sample standard deviation, and we got a sample size of 10. That's also another thing we got from that. I mean, we could count them, but you know, it does it for us. Why bother? Another thing here that we can get is, oops, let me see if this will let me work. Okay, degrees of freedom. So since I know the sample size, it's one less than that. My degrees of freedom is 9. So part A for 18 asks us, use a calculator with mean and sample standard deviation keys to verify this. So calculator did verify, okay? I think all of these are going to verify. If you don't have a calculator that does it, how am I going to know, really? There's nothing to show here. But if you do have a calculator, I would go through this, rewind the video, see how you put it in there, make sure you do it correctly. And so that, if you have to ever do a calculation for standard deviation or mean or something, you know how to do it on your calculator. All right, let's move on. B, use a 90% confidence interval. So C equals 0.90. All right. For the population average mean for this, providing at least some charitable care. So I need to go to my T table, and I need to look on my T table for 9 degrees of freedom in a confidence interval of 0.90. So 0.90, 9 degrees of freedom. I'm going to cross-reference that. 1.833. It's kind of hard to see because I made it smaller so I could have my calculator up here. But 1.833. So TC equals 1.833. Now I'm going to find my error margin. So remember, that is TC times the sample standard deviation over the square root of your sample size. And remember, sample size. So I'm going to take 1.833 times 8.0, so 8, divided by the square root of 10. Throw that in my calculator. Let's see what the calculator says. 1.833 times 8 divided by second square root of 10. Close it up. And that's about we'll say 4.6%. Right, these are all in percentages, what percent do this. So to get our interval, it's going to be our sample mean minus this error margin, and then it's going to be our sample mean plus that error margin. So 62.3 minus 4.6 and 62.3 plus 4.6, 4.6. All right, so 60, did not like that. All right, 62.3 minus 4.6. So 57. So what percent do this? Somewhere between 57.7 and we'll just do this. 40 is 66.9. So somewhere in that range is how many hospitals provide some charity care, some charity care. And then C, yes, interpret it. And all these interpretations are all basically the same. What does this confidence interval mean in the context of this problem? We are 90% confident the population mean of hospitals Hospitals providing charity is in this interval. In this interval. I can't write. Sorry, this kind of getting into a position here that making it a little harder to write. Okay, this interval. All right. And so they're all kind of like that. We are this % confident that this is in this interval. You know, that's pretty much how all these are going to go. All right. So for the rest of the assignment, do 13 through 17 odd. And that's it. That's all we're doing. So again, it's very similar to 7.1. The only difference is we're using this new table, because we do not have the standard deviation of the population. All right. And I will talk to you later. Goodbye.